So, hi everyone. Confirm you can hear me.
Yes, we can hear you.
Okay.
Yes, we can hear you.
All right. That is nice. So, how are we doing? I hope we are good. Okay. All right. So, yeah, I think we are starting a bit late today. But it's fine. We are going to cover what we have. All right. Thank you. Okay. So, before I share my slide, I think in our last session there were a number of questions that came up. So we're going to start the session addressing those questions. So if you have, if you asked the question the last time, or you still have questions around what we have discussed already, can you quickly unmute yourself, ask the question, or maybe drop it on the chat. Let's start a session. Yeah, because we're almost done. We have already touched all the aspects, various aspects. So today's session we finalize everything about.
Good evening.
Yeah. Okay. Good evening. I
Yes,
can hear you.
yes. My
Mhm.
question is related to simple regression and multiple regression. Remember the first time we did simple regression, we plotted a graph using regression. We used SNS to draw a regression plot. And we also used
Yeah.
scatter plot also. Because what I understood the simple regression is using a particular independent variable rather to predict
Mhm.
an outcome. And I
Mhm.
tried doing that with the with the multiple regression. Yes, I tried doing that with the multiple regression, and it didn't work because I've forgotten now. But I remember that I was unable to plot that graph because I just wanted to see if there was a line the same way that it was with simple regression, but that didn't work for the multiple regression. So I wanted to know if because I realized that while you took us on the training, you didn't plot a graph for the second one also. So maybe there was a reason why you didn't do so because maybe there was no need or maybe there was no relationship that could occur. Maybe that was why you didn't plot the graph. So I just had to ask now.
Okay. Yeah, I understand. I understand what you're talking about, right? You try to plot the graph. The simple regression. The relationship was actually between the dependent and
Independent.
a single independent variable. So, like just like you're plotting a graph of y against x, which is obviously very easy graph to plot, right? But now we are looking at so many features, so there are different features. So we are going to, there's no, like, you don't expect to have, that kind of graph, right? That exact kind of graph that we plotted for simple regression. So that was why when we discussed about simple regression, I didn't bother, bringing up the graph, right? So when we have multiple features like that, we tend to we not get that kind of graph. That's just the reality. But when you plot the graph, what error did you get? Let me see. Let's start with that.
So the thing was that I think it was the same thing you said. I needed to include multiple features. So, when we did simple regression, our X was our independent variable. I think we used bedrooms, and our Y was what at the price we were trying to predict. You understand, sir? But when I did for multiple regression, X had a lot of features. It had bedrooms, it had area, I think it had the basement, while Y was still the price. So because of that, it wasn't even plotting at all, and it got me a bit confused. And I realized that no matter how much I tried to input it, I needed a particular. It kept on asking me that it just wasn't working. I was getting a lot of error. And then I checked online. I discovered that it is not as straightforward to plot
Plot that particular graph. Yeah, because of the fact that you have many features. Just like you plotting a graph of, the graph is going to be more of, it's not going to be 2D kind of, because you're plotting a single variable against multiple variables. Just like I put a graph of y against, let's say, x, mn, and other features as such. So obviously, it's not going to be a simple straight line, as such. So that is just it. Okay.
Thank you.
So you try researching about it online, right?
Yes, I did so, and I saw that there were a lot of technicalities involved. Like there were something that I didn't understand, and that was why I decided to ask, because they were training me. It became too technical, so I was like, okay, let me put a pause on it for now. At least I got the idea of the regression, why the multiple regression, the simple regression, linear regression. I understood it.
Okay.
It's just that it's that graph that I really wanted to plot, and when I saw that there were a lot of technicalities around it, and it became too technical for me. I decided to put it paper, then maybe I'll ask you on our next session. So thank you for the clarification.
All right, it's fine. Then you can try other plots. Someone suggested the distribution plot, because obviously that linear graph will not work out. So you look at other graphs, right? So you can try. I think Kenneth mentioned a distribution plot.
Yeah.
So research about how to do that. Yeah, because you are in that case you have multiple features, so it's not just a single feature. Okay, right. Yes. So that is just try it. Part of what we do in this field is about researching and trying our stuff. Right? And don't be afraid of getting errors. When you get error, try to learn one or two things from the error and then you move on. Right. Good try.
Thank you.
Right. Fine. Okay. So someone said that he tried Regent and lasso technique, lasso run, Ridge keeps throwing up type errors. And see all these errors, is only when, because it's going to involve a bit of debugging. It's not something like someone can just look at and say, okay, this is the reason why we have the error. So, but we'll see to it. Let's see first.
All right. Good evening, sir, Mr. Kennedy.
Kennedy, yeah, thank you.
Yes, sir. My last question, I remember I asked vividly that using cross validation, so like my view is that I don't really know, because I know the SS in which they use cross validation and they use
Sorry,
the best.
You are breaking. I cannot hear you very well.
Can you hear me now? Hello.
Okay,
Hello?
Go ahead. Yeah, go ahead. Right. I can hear you.
So I really know that the best
continue. I can hear you.
Output. Okay, the best output will be pick, but my view is my point is, when are we going to, or where am I supposed to use cross validation? That's my number one question. And number two, I try to work on that lasso regression. So I try to see, but I observe that it is also used in getting the best features. But I want to ask that, is it every time will be right before we can pick any feature? Is it that we must use lasso, or can't we think or guess in our own way that, okay, this is how this can be the best features?
Okay. Yeah, you cannot use guesswork, right? You cannot use guesswork to do that, right? Because if you use guesswork, is actually going to be difficult for you. So that's why we have all those techniques. Is that okay?
All right. Okay. So
that's why we have all those techniques. I will show you guys. I'll show you guys how to implement them. I guess that is what we're going to use to conclude our sessions.
All right, so right. Sorry for emphasis. So the important thing in my question is, please, when to use that cross validation, please kindly emphasize on it. Please, I will love that, sir.
Yeah, sure. That is part of what we're going to look at today. So, but cross validation, basically, in cross validation, you have it's just like you are you know, we are trying to iterate. We have a lot of iterations. When you split the data into test and train, the truth is that the model, as the model fits into the train, right? Um, if the model fits into a particular train data and then learn about that train data and then use it to make predictions, right? So the truth is, if the model doesn't have a test of certain, let's say, data, it will tend to be biased towards that particular data setup. So we use cross validations to expose, almost all the data sets, right, to the model. Now, the cross validation, iteration is just like it will the system will select, just let a simple logic, select a particular portion of the data set, use it, for test, and then train on the rest. So it repeats the iteration depending on the number of of CV that you have in your setup. So, but I'm going to show you how to go about that, and I have an example that will work out very well. So I'm sharing my screen right away, so that we can see how this can be done. So can you see my screen? Can you see my screen?
Yes, we can see your screen.
Yes, we can
Yes,
see
we
it.
can.
Awesome. Okay, so let's just quickly. I know you guys have questions. Just keep your questions coming, right? Let's quickly finalize with what we started in our last session, right? When we had, I think there was a bit of network issue. So because of the fact that we have already done, a lot of this, I've already pre-populated this, so I'll just explain. I'll tell you guys, all the new additions that I've made to the notebook. I will explain them, right? So I think the addition that we have here, the new stuff we have here in terms of the libraries, happen to be the grid cross validation, the grid search. So we're going to use this for hyperparameter tuning, and then so I added this one as well, just for us to see this cross validation stuff in action, right? And then ridge and lasso, standard scalar for scaling the data. We have already done something with the metrics, the mean square error, and the R2 score and all the rest. So I'll go ahead and run this. Okay, so basically, we still follow all the steps, right? At the beginning part of your project or of your work, you have to import the necessary libraries. I have to pre-populate this, to save our time and all that. So let me quickly load the data. Now, just to bring in the new stuff, like the way you load your data depends on the structure of the data. Now, there is a reason why I added this delimiter and I use semicolon. I'll show you guys that, right? Let me just remove this and show you guys why I added that. If I try to read this data, you see that it's actually successful, right? There was no error. But if you look at this data closely, it doesn't look like a data. It's a data frame, but it looks crazy. It doesn't look normal, right? Like it's not well formatted as such. Now, but if you look at this closely, you notice that the separator here happen to be semicolon, right? So you can see it, everywhere, probably because of how the data was collected. So, and this stuff is true for both the headers and even the values. You can see all the values are separated by semicolon. So obviously, if you try to load this, because CSV file is comma separated, right? But what we have here, we have semicolon as a separator. In some cases, you have tab separated. Tab is this symbol. So you have something like this, separating the data. So when you have all these, if you have these separators other than the comma, you have to specify the delimiter, right, in your as you load your data, because that is what will make your data to be well formatted, right? Because this will instruct the system that, okay, the separator in this case is not the default you're expecting, because this is reading CSV, so it expects comma as a separator. But now the data here, they're not separated using comma. So, so that when you are working on a task and you load the data from that you got from somewhere, if you get this kind of funny shape, just try and figure out what the separator is, and then this is how you define the separator, and your data will be presented in the right format. Okay, so that is additional stuff that I added based on the type of data that we have. Then, basically when you load the data, you try to explore it, try to know the shape, and try to get some, look at the columns to know if you have null values and the type of data that you have, because that obviously will help out, in what you're going to do. Then also check if you have null values. So in this case, there is no null value, right? So that makes it very easy for us. Yeah. So the essence of the session is not to handle null values. That is why I have to use a data set that doesn't have null values. So now,
Sir, please have a question,
okay,
sir. Can I speak, sir?
all
Under
right, no
what
problem.
circumstance do we need to standardize our data using MIMA scale or standard scaler? Under what condition? Because in the example in our study material web, it was done by default. But the justification, I didn't see it there. I don't have to know, sir. What are the situations that, what's usually called for it? Is it a standard procedure, or there are some things that one will observe before such should be carried out? Thank you, sir.
Okay, so basically, when you are working with data, like as you have here, you have multiple features and they have different values. So some values are big, some values are big. Like as you can see here, you have 34, and you have this chloride 0.071, right? And all that. So when you try to train the model with the data, the features exactly how they are. So the model may tend to kind of be geared towards, in terms of distribution, towards these large values, right? So the standardization is just to make the values for each of these guys to be within a particular range. So if you use mean mass scalar, you will specify your mean and maximum value, right? Then if you use standard scalar, right, it does some statistical calculations behind, like at the back end, right, whereby it will use the standard deviation to normalize to make the values to be within, all the columns to have values within, between, just within the same range as well, so that the model will not be kind of, let's say, have, how will I put it, a distribution that be skewed towards one direction, that kind of a thing. So that is just right. That is just what is all about. And mind you, depending, because when you're working on all this kind of stuff, you right, is a lot of iterations and experiments, right? So because this whole stuff depends on the data you have. Sometimes the data this thing will perform, standard scalar will perform very well for a particular data set, and when you use it for another data set, it will not perform that way. So you just have to know all the possible, in this case, all the possible options, right? And then you try them out and see the one that works best for your data. But remember, when we did the last stuff we worked on, we didn't scale anything, right? So, but remember, the reason why we scale is just to make all the values to be within the same range as such. And it's very important in this kind of data. You can see, like, these guys are very small compared to other. This is 0.0, this one is 0.9. Why we have 34, and all that. So if we don't normalize this, then the model will not perform very well, because it's going to kind of drift more towards all these larger values than the smaller values. So that is just it. Is that fine?
Yes, sir. But I'm sorry to buttress on this. I know with the issue of outliers, is it responsible for such the distribution?
When you have outliers in your, obviously, if you have,
And
yeah,
one
I know
is
we did
large
mention
and
about
one is
outliers.
small.
Yes. So if you have outliers, because the concept of outliers depend on, yeah, I understand what you're saying. If you have outliers, obviously, right? The model, it will, exactly what I just explained, is going to generalize more on the large values. So that is why, you have to normalize, so that everything will be within the range. But there are some models that you must check for outliers, right? And you have to handle the outliers. For example, when you are looking at time series model, but I don't think we have reached, that should be the last stuff for data science guys, not engineering anyway. Is that okay?
Yes, sir. Thank you, sir.
All right, awesome. Okay, so so we separate now in this particular task, we are trying to predict the quality of a red wine, based on all these other features. So we have fixed acidity, volatile acidity, and all the rest. So we want to use this to predict the quality of the wine, right? So where this data set was actually downloaded, obviously there will be description in terms of these values, the range of value, like a particular value that will show you that the quality is poor, and high value that will show you that the quality of the wine is actually rich as such. So so in the pre-processing part of this, we have to, get the features. So in this case, we are not doing any feature selection. We are using all the features other than the quality. So that's
Please,
why
can you
we are
zoom in
talking.
your screen, sir, so I can?
Oh,
Yes, sir.
yeah, thank you. I actually forgot. Thanks for mentioning that. So how is it now?
Yeah, it's fair, sir. Yeah, perfect.
Okay, nice. Okay, so we have to drop the quality, right, column, because we want the feature to be everything apart from the quality. Then the y, which is the dependent variable, is what we're trying to predict, and that is the quality. So we just extract the column from data. So remember, I told you guys that this guy will be 2D, while this guy will be just 1D. So it's fine. So when you do that, we have also discussed about separating your train and test data. So we are using 20% for the test and 80 for the train, and that. So now, normalizing we are when you're talking about this normalization stuff, the scaling stuff, we are actually scaling the features. We are not scaling the what you're predicting, right? So um, because we are trying to use X to predict Y. So if you look at this, we scale. There are two ways to do this. You can scale. Okay, you can scale this X. Like, you can scale this X as you have it before separating your train and test, or you do it after you're done separating the train and test, and then you scale the S train and then scale Y trend. I will just run this and then show you guys what the outcome looks like. So if I try to view the S trend, trends, view this, you will see that I have here, right? Everything happened to, right? So values are far. So that is what the model will not be biased over. Make the model not to overlearn the feature. Shouldn't, you know, and then leave the small very well. Model will be biased as such. Sense of the scaling. If I
Sir, this skipping has restored back. Your voice is skipping.
The what?
Your voice has started skipping again, sir.
Seriously?
Yes, sir. I don't know if it's only me or others experience it. I don't know.
Yes, I'm also experiencing the same thing.
For how long now?
I just
Just
came
like 3 minutes or there.
5 minutes.
Just some
Okay,
minutes
boy,
ago.
can you?
Yes, we can hear you now.
Up to 3
Okay.
Is it
minutes.
breaking?
All right. So once you notice it, bring it up. Don't keep quiet, okay?
Still breaking.
All right, sir.
So all right, good. So you see what the S trend looks like. You can see that this guy even has up and so on and so forth. I don't want to start, have that, but it's just very clear. You can see the difference is obvious. Ellen does it to just, do some relation, right? And then for doing that,
So
then it will
sorry,
be
sir. You are still breaking up.
We did not get that part, sir. Is it
It
breaking?
keeps. Yeah, so we hear a part and then it breaks in the middle, and maybe we hear the last thing you say again.
But can you hear me?
Yes, right now.
All right. Okay, let's. Right.
We can hear you, but it's in parts. So when
It's in
you say
part again.
something like X train scaled, we probably hear only X train and we don't hear the scaled, or we hear X and then hear scale at the end.
Wow, that's strange. My coverage is actually fine.
Maybe we just have to manage like that.
Sir, are you on Bluetooth?
No, not at all. Speaking direct to the device. Okay. So, but my screen is visible.
I have an
Yes, your screen is
observation.
visible, sir.
I have an observation, sir. I don't know, maybe it can be.
Okay.
I observed, I just by chance went to YouTube to check the quality of our recording that was actually bad on Zoom. Why I didn't really experience these breaks on YouTube. I'm not sure, maybe it's not the push part. So I don't know, maybe the issue is from the channel of Zoom. Maybe people on YouTube may not have experienced it. I don't know if anybody also checked on Zoom, and in fact, you were crisp clear. Everything we saying, not everything was actually clear. So I don't know what could be the
Wow.
reason.
Wow, that's a good one. That as far as you guys can hear me now, all right, I can proceed. So confirm, can you?
I hear you. As it's breaking, I hear you.
But it's still breaking. That's the problem. You know what he said
Oh,
just now?
I'm coming. Just give me a moment.
All right, sir.
It was breaking on Zoom. Okay.
Okay, someone confessed now that it was also breaking on YouTube the last night on his chats.
Just give me a moment. Mm, Okay. So let me share my screen again. I guess. Right. So can you see my screen?
Yes, I can. We can see your screen.
Yes, I can.
All right, it's fine. I just made some changes. I hope. Okay, so fine. So yeah, for the
It's still doing the same thing. So I think when we started the session, it was clear enough. I don't know, maybe now dragging and connection.
it should be fine. There's no reason why. So you're saying that maybe in the last 2 minutes happen to be breaking.
So I just have, and this you're saying. So I guess when we started the session, everything was when you started running some, I don't know, from your end, 3 to
Okay.
4 minutes. Yeah.
All right, it's fine. Let's see how it goes. So this is the main part of this particular session. Working fine because I need you guys to understand us, right? Because the question in this, and that is about the hyperparameters. Now, in our last session, Ridge and Lasso, okay, perform hyperparameter tuning. Hyperparameter is just like you are trying to feed this model parameters. If you say the parameters, you'll be exhausted and not make a lot of sense. So the best thing you can do techniques to using a grid search. So in this particular regression, these are the parameters that function. Like for example, I think if you go to Google and search for the lasso regression, search for which, let me use lasso and show you guys. This stuff is just like a function, right? So these parameters, particular value that they take. For example, the alpha as a parameter has a default value of 1 from, now you need a way to, for the system to be able to pick the best value to perform the model. You see all those hyperparameters, just know that they're just like, right? So you have alpha, you have theta, actually online. When you go to official documentation, a lot of mathematics, so instead of us setting, set the value for alpha as 2, as true or false, and all those, make a list of these parameters. Automate the process of is what hyperparameter tuning is all about, right? Trying to set, these are the setting for alpha, non-negative. So all the values are positive, as low as 0.001. So this one we are setting up to 1, 2, 3, 4, 5. One can come here and use a range 0.001 to the number of that you have in this particular list, right? Computation that will be performed. Expensive, Okay, so alpha, then for the fifth inter, that true or false. Then we have, then just added all this stuff because these are the possible. We want the degree size, the best combination in. That is what we are doing here. So remember, you said, the model training. These hyperparameters will be used later on. So you do the same thing for lasso. It also has alpha as a parameter. Then it doesn't have solver, it has copy X. Then you're practicing, play around with the parameters in the lab. Also the same thing for ridge. Just see, what it's going to be like. Hyperparameter. Yeah.
I want to confirm something because it's just
Okay.
unfortunate that this issue of voice speaking has consistently, but I've already trained my model to fit to the methods. I'm trying to get exactly. My question, sir, is
Okay.
when do we do this parameter tuning? I read somewhere that we do it before we test. Am I correct? That is, I read that it is external. That is, maybe it's, you do it externally, but I didn't get it. I read that it is externally, that is not within the, it's not within the, it's not within the data. I didn't get what I read. So I was hoping that I was going to actually ask the parameter. Parameter tuning, but I don't understand.
Okay, yeah. Started with the tuning, right? So this stuff is just, we are setting the, like, these parameters are very important. Like I said, yeah, these parameters, there are some parameters of the model, like to set them up. That's why it's documentation. You will see all the parameters. This is for lasso, linear model lasso. If you look at the under the lasso model and look, yeah, right, you can see all the parameters that are associated. And the same thing is true for other models. So what you what you do is you select the parameters that kind of, some of them you just have to work with the default, right? Why you need to set a particular value. Now the question is, for example, now if you want to set iterations, the default is 1000. If you don't set it, the model, sometimes the number of iterations performed by the affect how the model will how the model, right? So okay, you can solve iteration as a hyperparameter. Then I'm now okay.
I'm sorry, I don't know, since I'm talking too much in this class, but I'm reading some people's mind. The breaking is just phenomenal. I'm enjoying this class, but I'm that this breaking is just frustrating. I wish you can have an extra class tomorrow, so 2 hours, take please so that.
I actually don't really understand, this break is actually fine. As you can see,
it's no breaking right now, sir, even now.
The breaking is not screen breaking. It is like your voice pattern is breaking. So maybe you want to say A, B, C, D. It will skip at B and C, then would hear D and E.
I hope there's no bug in let's see.
Enough, even in YouTube, it's also breaking on YouTube.
Yes, it
But
is
how
also
come,
there. It is breaking there also.
when we're having when we're having conversation like this, people will hear me very well. But once I start talking about this, then
even normal
even normal conversation is breaking.
Even normal conversation, you are breaking. So it's not as though it's when you are exactly.
that is actually. Let's see. Obviously, to complete this particular session, let me almost done. Coming. Okay. You guys hear me?
We heard what you said, sir.
Yes.
All right. Let me take. Okay. Okay, it goes. It's fine. So once you
Are you there, sir?
Please, I can't hear anything. Is it just from my hand?
No, I think it's general.
Okay. Thank you.
You're welcome.
These are missing values, so we need to use the missing values. That's it.
Sorry, can you hear me? I think I was disconnected.
Yes, we can hear you now.
You're back.
Yeah, I was disconnected. Okay. Wow. Okay. All right. I just hope that will fix the issue. Okay, so fine. So now after setting up the hyperparameters, right, we perform the tuning. So in the tuning, we are using grid search CV. So the grid search CV function takes in the model. So in this case, we are using Ridge. So that is why we have to create an instance of Ridge. So we're using Ridge regression. So what this guy will do is it will use the model like an instance of a clean model. This model has not been trained yet. So it will use an instance of this model and then perform training, like, because we are using, these are the parameters that we define up there for Ridge. Then we have the CV. So we have 5 iterations, right? So what this guy will do is he's going to, perform this particular, he's going to train this model using these 5, sorry, based on the parameter that we have here, right? So it's going to use these parameters in turn, and then, do the fitting. Then after fitting into the model, it will now kind of help us to predict the best parameters. So what we're doing now is, instead of us setting the parameters manually, we use this Ridge, to get the best parameters and then use the best parameters for the final training. So if I run this now, this will perform right. So if you look at this closely, the grid search CV, use the Ridge model and the hyperparameters that we set up there. Then with 5 iterations, it was able to, train on the data, the X and Y data, right? And then whatever that comes out of this, it has a method called best params. So best params is just a method, of Ridge CV, right? So this best param will help us to print out the best parameters that this grid search CV happen to, so like I said, it's going to perform training, the normal training, with all those parameters that we defined up there, then in 5 iterations. So for each of the training, it will evaluate, evaluate the model to see the particular parameters that will bring the best results. So after that, it will now output, that best combination. So what you now do is you use this guy for your final training. So the hyper parameter tuning only help to get the best parameter combination, right? Then once you get the best parameter combination, you now use these parameters to do your final model training. So this is now where you train the model using those best parameters. So there are 2 ways to do this. Actually, I just use a bit of Python stuff to a kind of break this guy down into the format. Okay, let me just show you guys what I mean. If I remove this guy here, I can replace this with stuff like, alpha equals to 100, comma, fit intercept equals to 2, comma, and solver equals to saga, comma, and then I run this, that works. So what I'm saying is that this stuff I have here, Okay, let me do it up so that you guys will see, because this is coding section. So if I do, let me try and see what happens. So if I do something like this, I'll print it. Let me see. Let me see. Let me see how what is going to bring. Okay, so if I print this, let me see. I know AFA is an invalid keyword for print. Yeah, so I get. So now, so what this guy, I know why this error came up, because obviously using these two guys, we use these two guys here because this reach CV dot best param is a dictionary. So what we're trying to do, we are trying to explode this so that it automatically use these guys as the parameters of the function. The print function doesn't have alpha as a parameter and all this other stuff. That is why this error came up. So I'll just remove this. So using this, we apply these best parameters into the reach function, and then we set a random state. So, and that we give us the best reach model based on the prediction of the hyperparameter tuning. So we do the same thing for lasso. We can as well use a function to do all this stuff, because we are repeating a lot of things. I'll show you guys something like that later on. But we repeat exactly what we did for Ridge. We do it for lasso, right? Get an instance of this, then use a degree search cross validation to perform the tuning, and then get the best parameter. Then after that, the best parameter is applied into the last modern function, and then the training will be done. So that is how this stuff, right? So you see, in this case now, we use hyperparameter tuning to get the best parameters, and then we apply the best parameters to the model function, and then do the model fitting based on the best parameters. So let me talk about this cross-validation, using this diagram that I added here. So in that grid search CV, what is happening is this. Now, there are different types of cross-validation, right? So we are using K-fold method because that is applicable in the research. So there are other methods, right? Even though all of them do the same thing. So cross-validation, what it does is it takes a portion of the data set, set it out for test, and then use the other portions for training. So what this guy will do, the first iteration will just take a particular set out for test, and then use the rest for training. Then the second iteration will now pick another set, right? A different set, leave it for test, and use the rest for training. So it will continue, that way until, based on the number of iterations that you have. So if you are doing 4 iterations, you just do that 4 times, right? And so the essence of doing this is for the model to get a test of all the data sets. Now, but I need to advise, we need to know how this value of CV, can affect computation. Now, we use, the more you increase the number of CVs, for example, if you make this 20, what it means is that the iteration is going to happen 20 times, okay? Now, if you look at this closely, you notice that if your data set happen to be very large, and you use this, use 20 iterations on the data set, it means that the whole thing is going to consume a lot of computation. Like, it's going to take time. So, because the truth is, when you are doing this in production, we can have data sets that will be in terabytes, okay, millions of rows, billions of rows, stuff that are very crazy like that. So if you use high CV for such setup, and your model can train for days or even more than that. Yeah, because I've trained a model that actually happen to last for hours. We have models that can train for hours and stuff like that. So, but our work is to not overkill the whole stuff. So if you have large data sets, right, you can use a smaller value of CV so that the computational let's say cost will not be that much as such. All right, because in some instances you have to pay for computation unit based on where you're running the model and all that. So the smaller the CV, the less the computation that will be done. So take note of that. Right. So when you're practicing, this, you can just try different values and just have a feel of. Just feel free. Like I said, feel free. Have a feel of the effect of the changes that you make as you are practicing. Okay. So now that we have this, let's see how the cross-validation scores will be. So the reason why I'm bringing this out just to show you guys what happens under the hood based on this cross-validation. So if I run this now what happened is this. When you run this, now we have CV set as 5. So it means that this guy is going to train 5 times. So for each of the training, remember, he's going to use a portion for the training and use another portion just to test and then, calculate the score. So now for the first one, it will get a particular score, then get another score for the so then the final output, the final score will now be the average of these guys. That's what I will come out. So when you perform cross-validation, you have like the training is going to be done. That's why I say the more the computation, because imagine you're performing, you have a terabyte of data and you now split this into 100. So it means that it is going to do the model training the first time, calculate the score, do the model training the second time, do it for 100 times, and then get the average of the results from the 100 iterations. So, and that is what the final score will now be. The final score will just be the average of, in this case, we have just 5. So it will be the average of these 5. If you set this as 2, it will perform, sorry, come in, someone raised his hand. If you set this as 2, it will perform this just 2 times, right? And then the average will be the final output and so on and so forth. So that is how this cross-validation works. So it will do the training the number of times based on your CV value. Do the training the number of times that you set as a CV value and calculate the score for each of the trainings and the testing, right? And then get the average so that the final prediction, the final result from the model will be, average is a better representation of the entire data. So in this case now, the average of this model will be a better representation of the performance of the model than using just a single value. Right, so that is that. So someone raised his hand up. Can you talk? Who is that person? Okay, Kenneth.
Yes, sir. Yes, sir.
Okay,
you said
right,
if we use cross validation score, it will give us the number of scores it gets in each of the iterations. Sir, does it mean that at each iteration the score gotten will be different for each iteration, sir?
Yeah, because it's using different data. Like, it's using
So
different
it will
portions
just
of the data. Yeah.
okay. Is it randomized sample or it's
Yeah,
just it will
sure.
just
It's randomized. Randomized. But
okay.
the system is designed in such a way. All these things are actually codes written by people, right? So
Yes.
what the system and someone can even think about it and even write a Python code that can do that. Like when you have data, to just do calculation and pick a particular portion, use it to train,
Yes, sir.
and then
Yes.
use another portion to test. Then after that, the next iteration, it will not, that one that you used, obviously it will know that it has used this one, right?
Okay.
It will not use another portion for training and testing again, get the result for that one. So it will do
Okay.
it based on the number of iterations that you have set, get the result for
Okay.
each of them, and then get the average. And that will be the final score. Yeah, that's how
Okay.
Stevie works.
Okay,
Make
I
sense, right?
understand. Thank you, sir.
Okay. All
Yes,
right.
sir.
Yeah,
Yeah.
my
Okay.
question, I initially raised my hand.
Yeah.
Yeah, it's still this same CV. So I wanted to just be sure. So the CV, when we specify CV to be 5, that means it's splitting the data set into 5 folds, Abi. And for example, using one of the parameters, it is going to iterate um
Five times.
or that particular parameter 5 iterations,
Yeah.
right? It's now
Yes.
going
Exactly.
another parameter and do another 5 iterations.
Yeah.
Okay, that's just
Not
one.
parameter, data. Use data because it's the data that you understand. So it's going
Mm.
to, yeah, sure. So it will take, like, because we are using K fold. K fold is just like the K value is just this 5 here. So, right. So it will be just, since we have it as 5, take the first portion and then the other portions will now be used for the training. Then one portion will be used for the test. So after it's done with that, it's take another portion for test, and the other portion will now be for training. Like, it will do that 5 times, obviously. So
Okay,
once it's done,
on one
you
particular
have
selection of parameters.
of parameter. Yes. So this one is even
Okay.
like I said, there are different types of cross validation. So you guys can check that out. That this one we are discussing the K food, right? So there's another one that there's one I can't remember the name, but it's just like something related to leave one out. So it leaves only one data set. It just uses to use one data set for test, and then train on the rest of the data set. So it's going to do this across all the data sets. For example, you have 100 data sets, it will use one for test and use 99 for training. So once it's done with that one, it will use another one for test, use the other remaining 99. So it will keep on doing this so that in such a way that the entire 100 data set will be used for training and testing. So obviously that will involve a lot of computations, right? Yeah, as such, because the essence of the cross validation stuff is just for the model to get a test of all your data sets, sort of, so that it will not be biased. You understand, right? That is the essence of the whole thing, right? So that it will get a test of all your data sets, then systematically use part of the data set to train and test. Then after that, it will give you the average. So that is what this stuff is all about. So the same thing for lasso, and then you have the results. So that is just it. Okay. So that is pretty what this is all about. We have already done this. Evaluating the model, obviously, that final score is what you have there. So, but if you look at this, notice that the score we have here happen to be low, right? So the score we have here is like 39, 40%. Okay. So obviously it can be improved. Like I said, when you are training a model, it involves a lot of iteration. Okay. So there's no way you expect that the very first training that you perform will give you the best result right away. So you have to go back and look at what you can do to improve the score. For example, this is linear regression, right? So there are certain things that we did not check. For example, there's something called collinearity, whereby some features are related, completely related, right? So in that instance, you can just use a single feature and eliminate other features and stuff like that. So when you go back and look at all those, I think we discussed that that was the first session. All those sort of what is that again? All those assumptions for linear regression, right? So if you go and check them out, then and try to implement like that collinearity I mentioned about, right? And again, do proper feature selection, because here we use all the features, even those that are not important, and they can add noise to the whole system, and then the model will not perform very well. So if you get a score that is not that awesome, right, it doesn't mean that that very first one you did is just the final. You have to go back and keep on iterating, changing stuff, checking things out, researching until you get a very good and the best score, right? Obviously, based on what the business requires as a best score, So that is just how.
What the threshold? What's threshold?
What is what?
The threshold.
Yeah, like I say, it depends on business requirement, because all this stuff, right? If you're doing this in production, there'll be a lot of discussions, right? Between the stakeholder, and so there'll be a lot of discussion. So it's the business that will set up the threshold. Obviously, some people, when they do this training, some people can get 90. Some people, when they are training, if they don't get 99, they feel like they have not gotten it, right? So, but it's just all theory. The truth is, when you start, solving real life problems, everything depends on what the business requirements happen to be, right? Yes. So that is just. But remember, the process of training model is an iterative process. You can't just get it once. So you keep on changing things, trying stuff, researching until you get the best results. So now the last thing we're going to do, like I said, we use all the features, right? So there's something called feature importance. So we can visualize the features, how important the features are in terms of predicting this. So I didn't want to repeat this for like I did here, because I think I repeated so many things for two different stuff. So I just created a function that will be a sort of template, which I can apply to both the ridge and lasso and get the result that I need. So this function is just very simple stuff. So I extracted the features as a list, right? And I have to remove the quality, because quality is not part of the features. Then feature importance is just a simple panda series. So just panda series. So since it's a function, I just have to add this model as a parameter. So this can take any model, right? So I just put model, reference it here, model dot the coefficient, right? And then the index will now be the features, like the column headers. So this one is not really important. I just added this just to label the plots, right? So just a simple if statement. If ridge is in the model name, I want the title to be feature importance for ridge. If it is lasso, I want the feature importance title to be for lasso regression. So I'll go ahead and run this. So once after this whole stuff is done, then you should plot the graph. So let me do this. Now, when we use functions, because if you start working on projects, you have to start thinking about how to keep your work to be dry. You don't repeat yourself. Like, all this stuff I did there because I wanted to show you guys certain stuff. Normally, if I'm working, you cannot see this kind of stuff in my notebook or my Python script. I'll use function for everything so that I don't have to repeat anything. So function will just be a template that will make your work to be very clean. As you can see, if I was repeating this stuff now, it's going to take like 5 cells before I can be able to achieve this and stuff. But with this function, I am good. I will just call the function and then set the model, and that is that. So if I run this now, it will plot the feature importance for rig. So for rig regression. So this will represent the features that contributed the most in that regression analysis. Like alcohol, you can see the extent of the contribution, the importance of this feature. This one is very small, the pH. Now, rig does not eliminate, it doesn't eliminate the features as such. So you still have the features, right? Even though some of them are very small, as opposed to Lazo. You see how Lazo will come out. If you run this, you see, because what Lazo does is, all those features that don't seem to be important, it will just shrink their coefficients to 0. So as you can see now, for density, there is no bar, 0 important. Like, it's not important as far as this particular regression analysis is concerned for Lasso. Then alcohol is obviously still very important. That is the most contributing parameter. Then you have residual sugar completely out. So that is what Lasso can do. Lasso can eliminate, can shrink coefficients that don't contribute that much to 0, completely eliminating them. So if I want to, something I can do is, instead of using this entire features, like sort of using all these features for my Lasso training, I can just decide to use only these ones that are important. I use the volatile acidity. I can use this one, even though it's very small, can still remove it. But, since Lasso did not see this as important, I can completely eliminate this and this. So what we do with this feature important is that after getting the feature important, we can, use it to do another iteration, another training iteration. But this time around, we're not selecting all the features. We only pick the features that are important as far as that particular model is concerned. That way, it will make the model not the feature not to contribute a lot of noise, and it can also improve the performance of the model. So you guys can try that out. So this is the first iteration. So your task will be to try and improve the score. Let it just go maybe to something higher than 50. Just try, let's see. And you're going to learn a lot, trying to do that. You're going to research a lot. And I would like to see the results after you're done. Okay. So we are going to stop here. I'll take your questions. I think that'll be fine. So Nathan, can you ask your question? Your hands are up. Hands up.
Okay, so my question is.
Okay.
Yeah, my question is, firstly, on the examples that were given on the site, now the codes or the lines that were written, the code lines that were written, I'm sure it was gotten from the data set. The data set for those plots, where do we or how do we access them?
There should be a link to the data set. There's no link. Is that what you're saying? To the data set?
I don't know. Maybe I'm the one
There
who's
should
wrong.
be links. Okay. Okay, fine. I'll ask the question internally to see but there should be links. For example, this particular notebook is already on the GitHub. And even this data set is also on the GitHub. So I'll find that. But there should be.
I want to be sure if it is the same thing as the original data set that was given. Because
Okay. No, not at all. Not at all. It's not the same. Because obviously we try to touch different data sets. Try to use different data sets for what you guys, so that you have enough data set to practice with. That is the essence of that. Okay.
Okay.
Yeah,
So all
that
of
is the
these
essence of
data
that.
sets now, so these data sets that we use, how do we get them? Or is it on the link repo?
It should
Is
be
it on
there
the
should be URL of those data sets. So, but check if there is no URL, then mention it on the Slack channel, right? So they will address it to be addressed for sure. Yeah.
Please, can you send the link to this file?
Hello,
Or
sir.
how do we get it?
Okay, is it this?
Yeah, to the code, the notebook.
Okay. So, I mean, right. So this, let me see. I don't know if you guys have access to this, but so this is a repo. Let me see. On this. Forgot that I was connected. Okay, so let me share this on the chat for those of you that are here. So that is where the notebook and the notebook for this session is. You see it there. Yeah, and remember, you don't
Thank
share
you.
anything you get on this call. You don't share with people that for anybody, nobody. Don't share with anybody, because if you're on this call, you have access to this. So pick it up right away, and don't share with anybody, so that those that did not attend the session will not enjoy the same benefit as you guys that took your time to be here. All right, see, so that is fine. Who else? I think, is there any other hand that is up?
Hello, sir.
Okay, all right.
Can you hear me?
Yeah, I can.
So, in a situation where we have we used grid search, and it took so long for it to do the computation. What can we do? Because I tried using grid search some days ago, and my system got my CPU got out of computational power, so it got to 100%. So I was even pitying the CPU. So in a situation like that, what can we do to make sure the grid search was successful, sir?
So what was the CV like that you used for?
I
And
used
how large is your data
the
set?
parameter grid. I used like four different parameters, hyperparameters that can be tuned. In each of them, I have a list of 5 items.
Okay.
Yes, I have a list of 5 items. While the last hyperparameter, I have like two. I have two. So
Okay.
it took a lot of time, and my system could not even process it, because it reached the maximum computational power I can do. So in a situation like that, what can we do to make it successful, sir?
So the thing is, it depends on the data anyway. Like how much your data set, what the size like? The data set you use
Like
for your
10,000 entries, sir.
10,000.
Yes.
Okay, 10,000. So because the thing is, like I said, if you have plenty, if you have large data set as such, right? So you have to minimize the number of iterations that can be performed. But
Okay.
like I will not say that you should split the data into different portions, then perform training on this, and then after that you now get the average of all those kind of stuff, because eh, um but obviously you just have to minimize the number of iterations, right?
Okay.
Yeah, you
Is
have to
is he
minimize
using
it.
Yes, sir.
Okay.
Is he using that CV parameter in grid search?
Yeah, sure.
Okay, sir. Thank you.
Yeah. So
I'll
yeah, you
try
have to
that.
minimize. Yeah, try it.
Okay.
Let's see how it goes.
Okay,
Okay.
sir.
All right,
Thank you,
fine.
sir.
You're welcome. So
Will
any
you be
other
the one taking us for next stage,
which
or if I stage C,
that,
so
for
that
data
I
engineering?
will yeah. No, data science.
Oh, okay. Oh no. I'm actually working with the engineering guy, but it's fine. We are
Okay.
working together.
So
Right.
how will I get if the outcome of the research? How will I get to you?
On the just put it on the
Slack
Slack
channel, right?
channel. Yeah, sure.
Okay. Thank you,
Anything you
sir.
put there, all of us will
Okay,
get it.
sir.
Okay.
Thank you.
So
Thank you,
yeah,
sir.
and again, you can also use Google Colab.
Okay.
Yeah, when you're working on stuff for now, you can use Google Colab so that you will not crash your system. Sometimes people think that this model training is just you just train model and model will train. Sometimes it takes a lot from your system. Sometimes
Yes.
if your system doesn't have enough, capacity in terms of memory, CPU, and all the rest, it can cause problem for your system. So
Yes.
you can also try Google Colab so that if it crashes, it can still come up again later on.
All right, sir.
Yeah.
Thank you.
Okay.
Thank you, sir.
Okay, guys. Yeah. Thank you for your patience and everything. We're going to end the call now, right? If you have any question or any issue, just make sure you put it on the Slack channel. And again, also try when someone posts a problem on the Slack channel, try and find solution to a problem. I also did this internship you guys are doing now, right? And that was one of the ways I developed myself. Like, I try my best to solve problem for others. So once someone posts a screenshot, a snippet or whatever error message, even if I don't know about the error message, I just pick the error message, take the personal, try to find a solution. And while doing that, I was able to learn a lot. So I guess that will also help a number of us and make this thing work out very well. So I wish you guys are the best for today. So we meet in the future. Take care, everybody.
All right. Thank you, sir.
All
Goodbye.
right, bye.
Thank you very
Yeah.
much.
Thank you very much.
Yeah.
Bye.
Thank you.